Trapped in jars or hidden away in boxes for hundreds of years lies over 135 million natural history specimens all around the UK. And the team at the London Natural History Museum are working to set them free.
I find the smells around the museum really fascinating, and often I particularly love when we open an old cabinet of something like tomatoes or herbs and you still get the smells 50 or 100 years after they were collected.
At the London Natural History Museum, the future of research is getting a taste of history as the team take on the mammoth task to digitise the collection.
DISCO UK stands for the Distributed System of Scientific Collections UK, which is a national programme to digitise natural science collections all around the UK. So I think lots of people love visiting natural science collections, and often what people think of and associate with us is dinosaurs, which is amazing, and we can learn a huge amount from dinosaurs. But also the wider picture, by looking at that history, we can build up a picture that then we can predict into the future.
The process is a little bit different from scanning the pages of a book. Each specimen is delicately photographed from all angles, and all of the information is input into the database.
We've got the country of origin, in this case it's Honduras. We've got the species, and in this case subspecies, and then we've got a unique identifier for the insect.
The database is free to access all over the world, and with 3 billion downloads from it so far, the demand from researchers is enormous.
So looking just at the moment, with I think less than around 6% of the UK collections digitally available, there are already more than 2 research papers on average a day citing those data, and that's across topics from freshwater, human health, evolution, conservation, climate, biodiversity, you name it, there's a paper that touches on it.
Before the database, it was a very different process for the researchers, who had to physically sift through the collections themselves.
If each paper represented one visit, and of course some would represent many visits, you've already saved something like £18 million globally in research efficiencies.
It's taken 10 years of meticulous work to get to this point, but with such great results comes more funding opportunities. And the team are now developing ingenious ideas to speed up the process.
This is a robotic arm which we're using to prototype new ways of mass digitisation of the insect collection. And so what it's doing is picking up a pinned insect, moving it into the staging area. And if you look closely, all of the labels of on the pinned insect, you couldn't read the labels by just taking a photo from the top. So it's now manoeuvring the camera around so it can read all of the text on the labels. So this is going to help our digitisation efforts, because a human digitiser will just work a set number of hours, and it's a very sort of repetitive, delicate task. But this can run all night long, all day long, and much faster rates than we can have with human digitisers.
In a world where AI is being trained on everything and anything digital, it's more important than ever for it to not just be learning about human history, but natural history too.
Natural science collections are this amazing treasure trove of data that we need to unlock. Nature provides our food, our materials, our medicines, provides inspiration for our arts and humanities and our culture. All of these things are things that we can illuminate from the data within collections by setting them free through digitisation.